Hey guys, this is one of our last lessons of this semester. It's like hopefully these next two videos are going to be fairly short. It's really just giving you guys information. I do want to say this about this lesson. I'm going to talk about 4 or 5 different kinds of quadrilaterals, and y'all should like take notes and write this down, and then keep this stuff with you so that when we're talking about these things, you know what the properties are. Think of these as like your cheat sheets, so that when we're doing work in class, instead of having to ask me every time, like, what is a rectangle? What is a square? How do these things relate to each other? You have this thing with you that's going to allow you to answer those questions on your own. So maybe you know this already. I guess we'll see what you know, what you don't know. But the word quadrilateral, this just means a polygon with 4 sides. So quad, 4 sides. Okay. So the first and kind of the most general kind we're going to talk about is it's called the parallelogram. It looks like this. Parallelogram is a quadrilateral with 2 sets of parallel sides. 2 sets meaning 2 sides are parallel and then 2 other sides are parallel. So like in this one, it's probably like these 2 sides are parallel and then these 2 sides are parallel. And if a quadrilateral is a parallelogram, it has a bunch of properties that go along with every parallelogram. And that's this next page. Every parallelogram has congruent, I don't know the best way to say this. Maybe I'll say opposite sides are congruent. Every parallelogram has, don't worry about that, but these are characteristics of every parallelogram. Every parallelogram has opposite sides congruent. Congruent. That's the worst handwriting ever. I'll try that again. Congruent. That means like these 2 sides are the same and these 2 sides are the same. So that's true of every parallelogram. Additionally, every parallelogram has opposite angles. I'm really struggling here. Opposite angles congruent. So like this angle is the same as that one, and this angle is the same as that one. That's true for every parallelogram. Every parallelogram also has the diagonals bisect each other. The diagonals bisect each other. And what that means is that if I drew in these diagonals like this guy and this guy, like that, if I drew those in, and then knowing that this is a parallelogram, I could then say that these are the same. I should do 3 because I already have a 2. And these are the same. I guess there's a 4th thing. If I remember what it is, I'll come back to it. These are 3 important things. There's a 4th thing, which if I remember, I'll say, and if I remember it later, I'll come back to it. But all these things are true for every single parallelogram. I guess I can say this. I can say that consecutive angles are supplementary. Supplementary. I think that was a 4th thing. What that means is like, if I label this thing A, B, C, D, and let's say this angle here is angle A and this angle is angle B or something. That means that I could say that angle A plus angle B is equal to 180 degrees. That's true for these two, and it's true for B and C, and it's true for C and D and A. Anytime you have two angles that are right in a row, they're going to add up to 180. So the consecutive angle is supplementary. That's true for every parallelogram. There may be another thing. I can't remember if that's the thing or not, but that's a thing. So parallelograms, these four properties, moving right along. A rectangle is a parallelogram with four right angles. Every rectangle is a parallelogram with the additional condition or something that, with the additional condition that all the angles are right angles. So still a parallelogram, but now we got a right angle here and a right angle there and a right angle here and a right angle there. So rectangular parallelograms with four right angles. And this is kind of important. And we're going to see, we have this like tree down here later, which we'll talk about in a minute. But the fact that a rectangle is a parallelogram means that it inherits all of these characteristics. The opposite sides of a rectangle are congruent. The opposite diagonals of a rectangle are congruent. They're all 90, so that's kind of obvious here. The diagonals of a rectangle bisect each other. And the consecutive angles in a rectangle are supplementary. So all of these characteristics we talked about for parallelograms also apply to rectangles. But there are some additional things that apply. Every rectangle additionally has additional characteristics of rectangles. Rectangles has congruent diagonals. Meaning if I were to draw, so like this diagonal and this diagonal are the same length. That's maybe obvious in a rectangle, but it's not true of every parallelogram. So it's important to note that it is true for a rectangle specifically. Another characteristic of rectangles that is important to talk about. Opposite sides are congruent, diagonals are the same. Diagonals bisect, that was in the previous one. I'll write four right angles. We already knew that, but maybe there's something else. So that's a rectangle. Big difference between a rectangle and a parallelogram is that a rectangle is a special parallelogram that has four right angles. A rhombus is a parallelogram with four congruent sides. In this case, all these, I don't know why this is so far down on the page. All these sides are the same length. This side, this side, this side, that side. They're all the same length. Some people think of a rhombus, it's like a diamond on its side, kind of, maybe. You think about it like that, but it has four congruent sides. It's called a rhombus. It's a parallelogram. So it inherits all of the properties of a parallelogram. Congruent opposite sides, congruent opposite angles, congruent, the diagonals bisect each other, and the consecutive angles are supplementary. So all those things are true in this, as well as it has four congruent sides. And it has some additional, it has two additional properties. In every rhombus, the diagonals are perpendicular. So this is pretty close to a rhombus. I don't know if it is exactly a rhombus, but it's close enough that if I drew these diagonals, I got myself 4 right angles in here. All these angles are right angles. The angles are perpendicular. So that's kind of a handy property. And also in a rhombus, the diagonals bisect. Diagonals bisect the angles, which means that like these two angles are equal, and that means that these two angles are also equal. And then these two angles are equal, and these two angles are also equal. So like I said, this is like handy stuff for you guys to like write down on your notes, and then make sure that you bring your notes to class with you, so that when we're in class and you're like, this is a rhombus, are the diagonals bisect the angles, you can like kind of flip through your notes and check and see that they do. So, all right, we're almost home now. Our second last quadrilateral is called a square, which y'all have likely seen before. And the way I generally, there's probably more than one way to, the way I generally define a square is a rectangle with 4 congruent sides. Basically, it's like a rectangle, which means that all these angles, it's a parallelogram with 4 right angles and with 4 congruent sides. You can also think of it like, it's like the intersection of a rectangle and a rhombus. It's like a rectangle where all the sides are the same, or it's like a rhombus where all the angles are 90. So it's like a rectangle with 4 congruent sides. And it's about the most specific of the quadrilaterals that there are. Every square has 4 congruent sides, and like everything bisects everything in these. So this is what I mean. If you draw the diagonals here, comme ça, like everything is equal. Like this is this is this is this. All these angles are right angles because it's a rhombus, so it gets that property. All the sides are congruent. This angle is 45. It's like all these angles are congruent. Like in a square, everything is nice and neat and tidy, and everything equals everything else. So that's a very, there's like not, a lot of this stuff maybe you could have guessed. Every square is also a rhombus. Every square is also a rectangle. Remember, a rectangle is a parallelogram with 4 right angles. This is a parallelogram with 4 right angles. Every, like, squares get the properties of all the things. Rhombus, rectangle, and parallelogram. And now the last one we're going to talk about is called a trapezoid. Now, trapezoid is a quadrilateral. That's not how you spell quadrilateral. It is a quadrilateral with exactly 1 set of parallel sides. And you can see I've drawn a few of them here. This is kind of a generic one. You see that the big arrows here represent the sides that are parallel. So you can see that this one set of sides is parallel and this other set is not. And in general, a trapezoid, like these sides can be different lengths, like this one is. This is kind of the most general kind of trapezoid you could draw. These angles can be different. That's fine. All right, those are totally different angles. And these are all different. You might be able to tell that if you add up this angle and this one, you're going to get 180 degrees. These are what in geometry we would call a set of like same side interior angles or something. Those are always going to add up to 180 degrees. Same here. These add to 180, but these two don't add up to anything necessarily. Here's a quadrilateral, here's a trapezoid, and these angles look like they're right angles. That's fine, still a trapezoid. These sides are different lengths, whatever. This doesn't have a special name, it's just called a trapezoid. This is a special trapezoid where these two sides are the same length. And this is called an isosceles trapezoid. Isosceles, meaning that these two sides are the same length. In general, in a trapezoid, we call the top and bottom sides the bases. And we call the sides that are, I guess we say we call the two sides that are parallel the bases, and the two sides that are not parallel we call the legs. That's just a name. Isosceles trapezoid has congruent legs, is one way to say that. Isosceles trapezoids have some characteristics that make it different from a regular trapezoid. For example, isosceles trapezoid has congruent diagonals. Like this, the diagonals are the same length. It has congruent, I'm going to call them base angles. The base angles are like these two angles. Those are going to be the same in an isosceles trapezoid. And that means that these two are also the same. Those aren't really, we tend to call the base angles the bottom ones, but whatever. That's about it for isosceles trapezoids, but they're like kind of like more convenient trapezoids. These two things are only true if these legs are the same length. And these ones, you can kind of see the diagonals are not going to be the same length. I think it's pretty clear that this angle is not the same as that one. This one is 90 and this one looks like it's acute. So those are like the characteristics, the properties of these quadrilaterals. This last page has what I like to call the family tree of quadrilaterals. It's like this picture, and this is like the most general kind, and this is the most specific kind. And like, there's like, the thing about this that I think is useful is that everything, you can think of this thing as kind of flowing downward. And everything that has an arrow pointing to it, like, inherits the properties of the things above it. I didn't talk about kites. Maybe we'll talk about those later. There's three different kinds of quadrilaterals. There's kites, parallelograms, and trapezoids. Forget about this for a minute. We'll talk about that later. So if something's like quadrilateral, the only characteristic is it has four sides. So all of these things have four sides. They inherit that from the quadrilateral. If the quadrilateral is a parallelogram, then we know it has two sets of parallel sides. For quadrilateral is a trapezoid, it has one set of parallel sides. So that's what happens here. And then a parallel, like a rhombus and a rectangle, are also parallelograms, which means they inherit the two sets of parallel sides and all the characteristics of parallelograms. A rhombus, as we know, is a parallelogram that has four equal sides. A rectangle is one that has four equal angles. And that gives these things special, like we saw rectangles like these, the diagonals are equal and they bisect each other. And in this one, we saw that the diagonals are perpendicular and they bisect each other. And then a square gets all the properties of both of these things because it's coming from them. It's like the child, right? It like inherits characteristics from the parents, so to speak. And the same thing here. A trapezoid has one set of parallel sides. An isosceles trapezoid gets all the characteristics of a trapezoid, but it has the additional characteristic of having two sides that are the same. So this thing can kind of get you a picture of like how these things are related to each other. And if you can remember that a rectangle is a parallelogram, then you know a bunch of things about it already without having to know anything else about it. So hope that was helpful. There will be another video about angles and polygons coming up soon. Bye.